Good morning, 7th grade. Today is Thursday, April 30th, and your objective is that you will be able to use tree diagrams to find the probability of a compound event. Okay. This is a reminder to review the grading rubric for this assignment because this is being graded differently than exit tickets, and it is important that you understand how you are being graded on all three parts. So please make sure you read through the rubric and then text me if you have any questions or technology issues. Okay, cardinals. Key vocabulary. So all of these vocabulary words are the same. We have a tree diagram, which is used to organize all possible outcomes for a chance experiment that can be thought of as performed in stages that show the event in the sample space. So compound events have more than one event within the outcomes. Compound events are, and then sample space is a list of all of the possible outcomes. And then I wanted to remind you that probability, remember we're on our module about probability. Probability is the measure of how likely it is that an event will occur. So if you remember the scale, probability is determined or is a value that is between 0 and 1. So 0 is impossible, it will not occur, and 1 means that it is certain it will occur. Okay, reminding you what probability is. Key points, these are the same from your assignment on Monday. Tree diagrams are used for calculating probabilities of events with more than one outcome, and the probability of each branch can be found by multiplying the probabilities of the outcome at each stage. We're going to work with that second key point today, and we're going to work with that second key point tomorrow before you start your exit ticket. Okay, the criteria for success is that you have a tree diagram, you have identified the sample space, and that you have your numerical probability written on your paper. Okay, number 1 for the Cardinals assignment today. It reads, I'm going to make this a little bit bigger because my eyes are bad. Okay. You are at a clothing store that dyes your clothes while you wait. You get to pick from 4 pieces of clothing, shirt, pants, socks, or hat, and 3 colors, purple, blue, or orange. If you randomly pick a piece of clothing and the color, what is the probability that you'll end up with an orange hat? So we are trying to figure out what is the likelihood that I will end up with an orange hat if I go to this store. So, I know this is kind of messy up at the top, but that's because I was a little bit confused at the beginning, but then I got it figured out. Okay, so to approach this problem, the first thing we need to do is meet criteria for success, number 1, which is to create a tree diagram. So what you can see here is that I have written out all of the possibilities of the outcome for the first event, which is picking the piece of clothing. So the outcomes could be a shirt, pants, socks, or a hat. Then from the first event, I have extended to show the second event, which is picking the color. So as you can see, I have a shirt that is purple, a shirt that is blue, and a shirt that is orange. So I had 1, 2, 3, 4 possibilities for my first event, and then I have 1, 2, 3 possibilities for my second event. Moving on to criteria for success number 2, writing out my sample space. Now, sample space is not a value. A lot of you guys on your exit ticket last week said that sample space was 5. Sample space is actually a list. So purple shirt, orange shirt, purple pants, orange pants, purple socks, orange socks, purple hat, blue hat, orange hat. That is the sample space in this problem, okay? Now I'm going to use my sample space to move on to criteria for success number 3, which is writing out the overall probability, the numerical probability. And referring back to my problem, I know I want the probability of an orange hat. So I'm going to look at my sample space. I can see that I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 different outcomes. And I know one of those outcomes could be an orange hat. So I could say that the probability of getting an orange hat is 1/12 by doing that. Or I could say, okay, the probability of getting a hat out of the first event was 1 out of 4. The probability of it being orange in the second event is 1 out of 3 colors. So I can multiply 1/4 times 1/3 to get 1/12. Okay, moving on to problem number 2 for the Cardinals. Make this bigger so I can see it. It says Justin lives in St. Paul and goes to school in Minneapolis. In the morning, he has 3 transportation options, bus, cab, or train, to school, and in the evening, he has 3 choices for his trip home. If Justin randomly chooses his ride in the morning and in the evening, what is the probability that he will use both bus and train? Both bus and train. Okay, so we have to first write out the possible outcomes of the first event, which is him going to Minneapolis, right? And he can do that with a bus, cab, or train. Then we have the event of him coming home, which again, he can take bus, cab, or train. So 1 out of 3 outcomes in the first event, and also 1 out of 3 outcomes in the second event. Writing out my sample space, I have 1, 2, 3, 4, 5, 6, 7, 8, 9 different outcomes. So him going there and coming back. Moving on to criteria for success number 3, the numerical value, we wanted bus or train. So when I go back and I look at my sample space, bus or train is viewed in only 2 of those overall outcomes. So the probability of him taking a bus or a train, both, is 2/9. Okay? Moving on to problem number 3 for the Cardinals. This one took me forever. Okay, if you roll 2 fair 6-sided dice, what is the probability that both of the dice will show an odd number? Okay. Criteria for success number 1 tells me that I need to create a tree diagram because this is a compound event. I am rolling a dice. I'm rolling a die twice. So when I roll a dice twice, the first event could have 1 of 6 outcomes. I could roll 1, a 2, a 3, a 4, a 5, or a 6. The second dice, I could roll a 1, a 2, a 3, a 4, a 5, or a 6. So this is what my tree diagram looks for rolling 2 dice. Moving on to criteria for success number 2, I have created my sample space. So looking at my sample space, I can see that there are 36 different outcomes because I have 6 outcomes for the first event and I have 6 outcomes for the second event. 6 times 6 is 36, and if I count all of these, I will count 36 different outcomes. Now I have gone through and I'm looking at criteria for success number 3, which is the numerical value of both of the dice showing an odd number. So I'm going to count up the outcomes from my sample space that show an odd number. And I count 1, 2, 3, 4, 5, 6, 7, 8, 9 different outcomes showing me 2 odd. So I have 9 out of 36 outcomes being odd. And then I need to simplify this fraction to become 1/4. The probability of both die being odd is 1/4, or a quarter of the time that will happen. Okay, last one, Cardinals, number 4. You are playing a game where you defend your village from an orc invasion. There are 3 characters, an elf, a hobbit, or a human, and 5 defense tools, magic, sword, shield, slingshot, or umbrella, to pick from. You randomly choose your character and your tool. What is the probability that you will be a magic elf? Okay. So there are 2 events occurring. I'm picking my character and then I'm picking my, I don't want to say weapon, but I'm picking my tool, right? So the first thing we do, criteria for success number 1, is to create our tree diagram. So the first event is us picking our character. First event is us picking our character. I have 3 different characters. Then moving on, I have my second event, which is picking my tool. And I have 1, 2, 3, 4, 5 different tools to pick from. So after I create my tree diagram, I create my sample space. For the sake of time, I just did the sample space for elves, knowing that I would also have 5 outcomes for the hobbit and 5 outcomes for the human. Okay, this is just saving me some time. Moving on to criteria for success number 3, which is the numerical probability of it being a magic elf. Well, if I go back and I look at my sample space, I know that there is only 1 out of 5, 10, 15 outcomes representing a magic elf. So the answer would be 1/15. Okay, Cardinals, I know that this, and everybody else, I know this is a 7-problem assignment, but I think that you guys are very much capable of getting a 100% on this assignment. Please call or text me if you have any questions or if you are having technology issues. Make sure that you have taken quality notes over the examples that I have given today. You don't need to recopy anything from this PowerPoint that you already have from Monday's assignment. And tomorrow when you take your exit ticket, please be sure to watch the video that I link, because I'm going to model a problem exactly like the problem that you're going to see on your exit ticket. So that should help you be successful on your exit ticket tomorrow. I hope you guys have a great day, and I miss you.